Hi guys, today we continue our journey in finding roots of equations using numerical methods. In the previous episode, you learned about the bisection method, but the bisection method converges at a very slow speed. Today I want to discuss a faster method called the secant method. The other advantage of this method compared to the bisection method is that the values of f at the initial points do not require to have opposite signs. So let's go. Here's the general idea. You need two starting points on the x-axis. I call them x0 and x1. Now the corresponding points on the function are y0 and y1. So we have 2 points on our function. If you draw the line connecting these points, you see it intersects the x-axis in a point we call x2. Then I repeat the process with x1 and x2. I connect these 2 points, find the x-intersect, and that's x3, and so on. Now from a mathematical point of view, the line connecting the points x0, y0 and x1, y1 is y equals to m times x minus x1 plus y1, where m is the slope of the line. Now to find the x-intersect, y must be set equal to 0, and by reordering the equation, we find x2. And the general formula to find the n plus 1 point is this. Let's put it into a code in MATLAB. I write a function named secant. Its input arguments are f as the equation we want to solve, x0 and x1, tall as the precision of the root, and another argument named max iter. In case the code did not converge, this value stops the loop to avoid infinite loop. I define the values y0 and y1. R stands for the error, which is the absolute difference of x1 and x0. And initially, iter is equal to 0, since we haven't iterated yet. Now, while the error is bigger than the tolerance, and we haven't reached the maximum number of iterations, the loop continues. The next point, called x, is calculated using this formula. Now with each step, the values for x0 and x1 must be renewed, so our points are shifted backwards. x0 equals x1 and y0 equals y1. Also, x1 equals x and y1 equals y. At the end of each iteration, the error must be calculated to check if we have converged to the root, and the iteration counter must be added by 1 to check if we have reached the maximum number of iterations. 2 things left. First, we have to display the result. So I display the iteration number x1, y1, delta y, and the error. I also add a few lines to make my results more readable. And in case the result didn't converge, I display a message to let the user know about that. Let's check our code to see if it works. I want to find the root of this function. I set x0 and x1 to 1 and 2, and the precision I want is 10 to the power of -4. I also set the max iter to 10,000, and here is the result. Thank you for watching. I hope I'll see you in the next video, and bye bye.